Good morning, guys, and welcome back to Dynamics. In this video lecture, we're going to start a new chapter which is about kinematics of a rigid body. Remember, guys, in the first chapter that we considered in Dynamics, we described the kinematics of what? Of a particle. So what's the difference between particle and rigid body? In fact, guys, the main difference between rigid body and a particle is that the rigid body is a set of particles. It contains particles. In fact, if you remember from the previous videos, we can say that this body is considered as particle if the size or the shape are considered neglected compared to other sizes and shapes in the problem. Now, if not, if the size and shape are not considered neglected, then this is called a rigid body. So I can say that a rigid body is a set of particles collected together. However, what you have to know and what you have to put on your mind is that a rigid body is a non-deformable body. What does this mean? This means that any distance between 2 points of this rigid body will always be the same, will always be constant in magnitude. It's not constant in vector because in fact I can experience a rotation inside a rigid body. However, the distance between 2 points inside this rigid body will be always constant. Now, there are 3 types of motion for the rigid body. I can have a translational motion, I can have a rotational motion, and I can have both of them, which is also called the general plane motion. But of course, there is a difference between these types of motion. In fact, if I have a rigid body, as we said, means a non-deformable body. A non-deformable body means that the distance between any 2 points will be the same for any type of motion. Alright, so since the distance will be the same, then the magnitude of any vector AB inside this rigid body will be constant. However, the vector is not necessarily constant. Now, if I have a translational motion, even if it is a curvilinear translational motion like this case, so if it is a rectilinear translation or a curvilinear translational motion, you have to know that the vector AB will be always constant in vector. So in translational motion, AB will always be constant in vector. It's constant in magnitude because this is a rigid body motion, this is a non-deformable body. And it's constant in vector or it's constant in direction because this is a translational type of motion. Now, for the rotational motion, of course, it will always be constant in distance or in magnitude because this is a rigid body motion. However, it will not be constant in vector since this is a rotational motion. So, of course, it will never be constant in vector. So here AB will never be constant in vector. This is in fact because I have a rotational motion, so it will never be constant in vector. And this is also, of course, applied to the general plane motion because inside the general plane motion, I have a translational and a rotational motion. In rotational motion, the direction will vary, which means AB will not be constant in vector form, which means I'm not going to have AB constant. So as we said, this is that translational motion could be rectilinear, could be curvilinear translation, and in this case, every line segment on the body remains parallel to its original direction during the motion. Since it's parallel in the same direction and it's already constant in magnitude, since this is a rigid body, then I can say that AB is constant in vector form. Now, if I have a rotation, in this case, the body undergoes a rotation about a fixed axis inside this body, which means all the particles of the body, except of course those on this fixed axis, will move along a circular path in the planes that are perpendicular to this axis of motion. Now, if I have both the translational and rotational motion, then the translational occurs within a plane and a rotation occurs about an axis that is, of course, perpendicular to this plane. So in the general plane motion, I'm going to have both types of motion. So if I want to start by the translational motion, we said that in translational motion, AB will always be the same. So what is AB? If you remember, guys, AB is in fact RB with respect to A. So I'm pointing to B from A, which means AB will be equal to the relative position of B with respect to A. Now, if I take effects reference outside this rigid body, and I call my origin O, and I need to find the position A and the position B. I know that the position A will be RA, and the position B will be OB. And then this means that RB will be equal to RA plus RB with respect to A. However, I'm sure that RB with respect to A is always constant in vector. And why is it constant? Because I have translation, which means if I do the derivative with respect to time to find VB in terms of VA, then I'm going to have that VB will be equal to VA, because the derivative of RB with respect to A is equal to 0, since this is a translational motion. And then if I do the second derivative to find the acceleration, I'm going to have also that AB is equal to AA, which means in translational motion of a rigid body, all the points in this rigid body subjected to translation will move with the same velocity and same acceleration. And this is, of course, not applicable to the case of what? Of rotational and then of the general plane motion.